Okay, CONTAM for ventilation design. Here we're going to create a basic enclosure and define some facade properties for a construction with a known leakage of 2.5 litres a second per square metre at 50 pascals. Let's start with a basic 1 cubic metre enclosure. Select draw boxes from the toolbar and draw a box. This doesn't need to be to scale. Now we deselect draw boxes and we need to define something about this enclosure. So CONTAM calls these zones. We'll double click somewhere here. Zone properties, we'll call this enclosure. And we'll set a floor area of 1 square metre. Now this will default to 3 cubic metres because of my default data, my default parameters for floor heights. So I'll say OK there for now. Go up to level, edit level data, change the distance to the level above to 1, replace that, yes, and close the level data. Okay, so now we have the zone named enclosure. It has a volume of 1 cubic metre, an area of 1 square metre and a height of 1 metre. Next we're going to try and introduce some air into the space, so we pick a spot somewhere inside the enclosure, we right click here and we say supply. So we get a new icon for the supply which we can double click on. We can write 2.5 litres a second, but because we haven't defined an air handling system it's not going to allow us to go much further. So we'll define an air handling system, come back to this icon in a second. So pick somewhere outside the enclosure, just anywhere, right click, select air handling system to add an icon for an air handling system. We'll double click on that, we'll give it a name, AHUSA, that'll do for now. Now we'll come back to our supply air icon, double click on it, 2.5 litres a second, and we can choose an air handling system from the drop down now. There's the one we just created. So we'll say OK. Now if we try to run the simulation, it's going to quite reasonably tell us that we haven't connected our zone to the ambient. So inside the box isn't connected to outside the box in any way because it's sealed by the enclosure wall. So this variable flow link it's talking about, we're going to go and add an air path. So we want to add another icon. Just click somewhere on the enclosure wall and right click, we say flow path. So we've got a new icon there for a flow path. We'll double click on that and we're now going to create a new element for this air path. So we'll choose leakage area data. We'll say OK. We're going to call this one block, like for a block wall, and we're going to say per unit area for the leakage area we're setting. We're going to take a guess to start with at 10 centimetres squared per metre squared of wall. We'll say OK to that and OK to that. We've now defined enough information to run our simulation, so we'll say simulation, run simulation, save the file. So then we start simulation, solves very quickly, we close that, and we get some information now coming out of the model. So there's some green lines representing flow, and to the right is positive. So our supply air here, we have 2.5 litres a second being supplied into the room, it's positive, it's a green line. Now we've also got a green line moving through the flow path here because we've got flow moving through there. We've got our 2.5 litres a second now leaving in the enclosure, which is what we'd expect. That's happening at about 10 pascals across that boundary. So that pressure drop's a bit too low for what we're targeting. We want to get that up to 50 pascals. So we're going to change this flow path data. So we'll double click on the icon and we go to edit element. Then we change our per unit area. Let's go down to 3. Say OK. OK, run the simulation again, and we can see now we're getting our 2.5 litres a second coming through there, and that's at nearly 66 pascals. So that's a little bit too airtight now, so we need to come back just a little bit the other way. So we'll go double click on the icon, go to flow element, edit element, we'll go 3.6, OK, OK, and we'll run the simulation again. And there we go, pretty close to 50 pascals. So that'll probably do for what we're after. So we've now defined a wall element here, and that's 1 square metre that we're working with at the moment. So we have 3.6 centimetres squared per metre squared per unit area of leakage area for this block wall that we've defined. We'll say OK, and then OK. Now we can extend this a little bit. We can change that from 1 square metre to 10 square metres. So we double click on the icon and we go flow path. That's currently through a total area of 1 square metre. Let's just increase that to 10 and say OK. We'll run the simulation and we'll see that we're getting 2.5 litres a second going through there at a bit under 1.5 pascals. Let's increase the supply air quantity. We'll double click on the icon. Let's go up to 25 pascals. Sorry, 25 litres a second. Run the simulation again. And we see we've got 25 supply. Over here we've got 25 leaving, and we're up at about 50 pascals again because the area is 10 times what we started with. So 10 times the air, 10 times the area. Now we can also add another air path. Let's say over here, we'll go to view and then normal mode to be able to add a new icon. Right click, flow path, double click on the new icon. We'll use the same block path and we will edit that element, and let's keep the properties the same here, so it's the same leakage, but we'll go to flow path and we'll say total area is 5 square meters. So this is half the area of the other wall. Say OK, run the simulation, and we see that we've got our 25 litres a second supplied into the enclosure. We've then got 16 or 17 litres leaving through the 10 square metre wall here at about 27 pascals, and through the smaller wall, 5 square metre wall, got about half the airflow there, just over 8 litres a second at the same pressure, just under 27 pascals. So that's how we define facade leakage for the purpose of ventilation design modelling.